Now listen to part of a talk in an astronomy class.
All right, so just to quickly pick up where we left off, the ancient Greeks and Romans believed there were 7 planets. All these were visible to the naked eye: Mars, Jupiter, Venus, Saturn, Mercury, the Sun, and the Moon. Nowadays, we don't consider the Sun and the Moon planets, but as of right now, we have 8 planets in our solar system. Well, 9 if you count Pluto as a planet. Anyway, so we have Mars, Jupiter, Venus, Saturn, Mercury, Earth, and of course later, Pluto, as I just mentioned, which gives us 7. What 2 planets are we missing here? Jeff?
Uranus and Neptune, I think?
That's right. The discovery of the planet Neptune was one of the highest points in the development of gravitational theory. You might remember that most people before this time believed in the geocentric view of the Earth. That is, that the Earth was the center of the universe and that the Sun and the Moon and the rest of the planets revolved around it. And it was Copernicus who first proposed the heliocentric model. That is, that the Earth and the other planets in our solar system revolve around the Sun. Still, it took a couple hundred years for scientists and researchers to eventually change their view and admit that the heliocentric model was and is indeed accurate.
Professor, why did it take so long for people to agree with Copernicus? I mean, didn't the heliocentric model make more sense? Of course the other planets don't revolve around the Earth.
Well, I think it's natural for us humans to believe we are the center of the universe. But besides that, Copernicus couldn't explain the reason why and how the planets revolved around the Sun. The geocentric model had been accepted for over 1,000 years. Copernicus couldn't prove his hypothesis. It was just a theory. Now, this is where the hero of the story of the heliocentric model, gravity, comes into play. The motion of the planets had to be explained through some type of mechanism, and that turned out to be gravity. And it's the gravitational pull that eventually helped astronomers understand how the planets revolve around the Sun. And that leads us to the discovery of Neptune. Okay, so let's see who did the reading. Can anyone tell me who discovered Uranus? Kim?
It was William Herschel in 1781, I think. Well, other people had seen it before, but he was the first to classify it as a planet.
And you remembered the year, too. Very nice. Right, so in the decade following its discovery, the orbit of Uranus had been calculated. But there was a problem. Uranus didn't move in the orbit predicted by the theory of gravitational pull. And by 1840, over 50 years after it was called a planet, it was clear that Uranus did not move in orbit according to the one predicted by gravitational theory. In 1843, John Couch Adams, a young Englishman, began a detailed mathematical analysis of the motion of Uranus to see whether they might be produced by the pull of an unknown planet. He guessed that there must be a planet more distant from the Sun than Uranus, and then determined the mass and orbit it had to have to account for Uranus's strange orbit. About a month later, an astronomer in Germany started to look for the planet. He quickly found and identified it. It was less than a degree from the position predicted by Adams. The discovery of the 8th planet, now known as Neptune, was a major triumph for gravitational theory because it dramatically confirmed its laws with a great deal of accuracy. This discovery was a major step forward in combining gravitational theory with careful observations. Such work continues in our own times with the discovery of planets around other stars. And that leads me to